I am highly excited to welcome you to Mathematics Simplified. My name is Joseph Jacob. Today, we are considering the introduction to a new topic, sequence and series. What comes to your mind whenever you hear those two words, sequence and series? Perhaps a group of things that are well arranged, things that are placed logically, things that follow the order according to a specific rule or arrangement or principle, things that are not in a haphazard form or placed anyhow. If any of these expressions come to your mind, you are right. But in mathematics, when we talk about sequence or series, we are talking about elements. These elements are often numbers that are arranged in a particular order. They are arranged in such a way that after looking at some of them, you can predict the next number that should follow because of the way they are well arranged. Let's look at three sets of numbers. In the first line, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From this set of numbers, you can deduce that they are well arranged. After 1, the next one follows is just addition of 1. When you have 1 for the first number, addition of 1 will give you 2, addition of 1 will give you 3, addition of 1 will give you 4, addition of 1 will give you 5, continuously until 10. So we can say that this number is sequential or it is a series. Look at this other set of numbers. 1, 3, 5, 7, 9. Do you think that these numbers are series? Yes, they are. If you look at it properly, you'll notice that there are no even numbers. We only have odd numbers. And when you have 1, you only need to add 2 to have the next number. When you have 1, you add 2, it becomes 3. You add 2, it becomes 5. You add 2, it becomes 7. You add 2, it becomes 9. So you see that this set of numbers follows a certain rule. So it is sequential. Let us look at another set of numbers. 1, 4, 7, 10, 13, 16, 19. If you look at these numbers from the surface or just lightly, you will think that they do not follow any series, any sequence, but they do. If you look at it very well, you'll notice that after each number, you need to add 3 to get the next number. When we have 1 as the first number, when you add 3 to 1, you have 4. When we add 3 to 4, you have 7. When we add 3 to 7, you have 10. When we add 3 to 10, you have 13. You add another 3, you have 16. You add another 3, you have 19. So this group of numbers also follows a particular sequence or series. Now, let's look at the two types of series or sequence. We have what we call arithmetic progression and we have geometric progression. What is an arithmetic progression? When we say that a series of numbers is an arithmetic progression, we are saying that the difference between a term and the one preceding it is constant. The difference between a term and the one preceding it is constant. Look at the last example we just considered. When we have 1, the difference between 1 and 4 is 3. The difference between 4 and 7 is 3. The difference between 7 and 10 is 3. The difference between 10 and 13 is 3. The difference between 13 and 16 is 3. The difference between 16 and 19 is 3. So this group of numbers are following an arithmetic progression. So in arithmetic progression, we have what we call a common difference. That common difference is the difference between a term and the one preceding it. There is always a constant difference between them. And that difference is called the common difference. Now, if you are given the first term of an arithmetic progression and you also know the common difference, you can calculate the number that will fall in 2 million or 3 million terms ahead. You can also calculate the sum of a number of terms. You can also calculate the average of the sum of a number of terms. We are going to solve problems on these points I raised in our next video. You know, this video is just an introduction. Enough of arithmetic progression. Let's talk about the geometric progression. The geometric progression is a bit different from the arithmetic progression. Remember, we've said on the arithmetic progression that it's about a common difference between the terms, isn't it? But in geometric progression, it is not actually like that. Instead of looking at common term or common difference, we look at common ratio. So a geometric progression, in each term, there is a constant multiple of the preceding one. In geometric progression, each term is a constant multiple of the preceding one. So unlike in arithmetic progression, where we talk about common difference, in geometric progression, we talk about common ratio. Now, look at this set of numbers. We have 1, 3, 9, 27, 81. This is a typical example of a geometric progression. You will notice that the difference between 1 and 3 is not the same as the difference between 3 and 9. It is not the same as the difference between 9 and 27. It is not the same as the difference between 27 and 81. That is why I said that in geometric progression, we don't talk about common difference because you will not find it. Rather, we have a constant multiple which we call the common ratio. In this group of numbers, can we say there is a common ratio? Yes, there is. That common ratio is 3. Remember, we said that in GP, each term is a constant multiple of the preceding one. Now, look at this group of numbers. The first one is 1. Remember, I said earlier that the common ratio is 3. 3 times 1 will give you 3, which is the next number. 3 times 3 will give you 9, which is the next number. 9 times 3 will give you 27, which is the next number. 27 times 3 will give you 81, which is the next number. You see how it works. So geometric progression is a bit different from arithmetic progression. Still, when you are given the first term or any term and the common ratio, you'll be able to get 2 billion terms of that series. You'll also be able to get the sum of a geometric progression. You can also calculate the average of the geometric progression. So these are some of the problems we'll solve about geometric progression and arithmetic progression. It's going to be very interesting. So make sure you join us when we start solving problems on sequence and series. This is where we'll call it a day for today. From our next video, we'll start solving problems first on arithmetic progression. Then in our subsequent videos, we now solve problems on geometric progression. Thanks for watching. Have a wonderful day. Bye-bye.